Ladies and gentlemen, please welcome Mr. Sagar Sharma and our panelists on the stage. Thank you.
Hi, am I audible? Yeah. Good morning, everyone. Welcome to this panel discussion. And since morning we were discussing about the high precision manufacturing and the opportunities which lies in that sector. And as highlighted, in the inaugural session and just before this particular session, that the importance of semiconductor manufacturing to our economy and the kind of value add which this particular industry will bring to our country, our economy, and also we will be an integral partner to make the semiconductor supply chain more diversified, resilient, and trusted. So, in that context, this panel discussion will particularly focus on the various nuances and the challenges of building the semiconductor manufacturing facilities, and I'll also sort of put a context to this, that how the level of precision which is required. So, for example, all of you are using your Apple iPhones, and the chip which are the processor which is driving your iPhone is being manufactured by something called an EUV based lithography, and that machine is basically, I think, one of the most complex things that the humankind has ever built. And we have done the neurosurgeries, we have gone to space, but nothing comes closer to the EUV machine. So so there's a generator in that machine which generates 5,000 tin droplets. Then there are very precise mechanism to shape those tin droplets, and then those tin droplets fall into the silicon wafer. And the precision of falling in silicon wafer is like hitting an apple on the moon from the earth. So that's the level and the complexities of the semiconductor manufacturing which offers. So in that context, we have, I think, the entire semiconductor value chain in this panel. We have CMOS semiconductors, we have packaging, we have memory manufacturing, and also display manufacturing in the panel, apart from the equipment and the raw material perspective. So I'll just request the panelists to quickly introduce before we go into the questions. So I'll start from Rishi.
Thank you, Sagar. Good morning, everyone. My name is Vishwanath Ramaswamy. I think a slight correction there, but you can call me Vishy. I am based here in Ahmedabad. I manage the Micron facility here, and looking forward to the pioneering the semiconductor manufacturing in Gujarat, in India. Thank you.
Hi, good morning, everyone. My name is Satish Amardar. I worked in semiconductor laboratory at SCL for about 31 years. I was responsible for setting up the fabs at SCL, starting with 6-inch CMOS fab and then 18-inch CMOS fab and the MEMS fab. So after completing my tenure, I was involved right from the greenfield projects, right from planning to the design, to the implementation of the projects, and then the process technology transfers from overseas partners, process startup, the operations of the facility. So after completing my tenure here, I joined, I'm a part of the Tata Electronics team and a member of the team for building the first commercial fab in India at 28 nanometer technology and 300 mm fab. So looking forward to interaction in this session. Thank you.
Hi, I'm Arun Gandhi. I'm with Tata Projects, heading the business unit for the semiconductor design and construction. I've been in the field of engineering and construction of advanced technology facilities for 30 years. A lot of the time was spent overseas as well, in the US, Singapore, Malaysia, and also setting up operations for Excite in India in my earlier days. So happy to be here, happy to be part of finally the semiconductor manufacturing taking off in India. There's been previous cycles that I was a part of when there were previous initiatives and which didn't quite, manage to take off. So happy to be here and participate.
Good morning, everyone. My name is Varun Manwani. I'm the CEO of Sahasra Semiconductors, a part of the Sahasra family. Sahasra is an OSAT ATMP. We set up the project in the year 2021, which is when we started construction of our OSAT. We basically aim to be part of the semiconductor value chain within India and for our global customers. And we will be packaging devices ranging from memory solutions, QFNs, SOPs, QFPs, and so on. Very delighted to be a part of this panel, and we'll share, all the insights of our journey so far with everyone here. Thank you.
Hello, good morning everyone. I'm YJ Chen. I'm from Taiwan. I'm the CEO of Redenta Display. I joined Redenta last year. I want to build the first display fab in India. I'm good in display manufacturing. I used to work in China many years to build for display fab. So I'm glad here to share my experience to you. Thank you very much.
Hello everyone, I'm Mr. Kwon from Korea. I'm so sorry I can't speak English well, so I use Korean. Please understand. 저는 한국에서 온 권지훈이라고 하고요. 지금 주식회사 아론이라는 곳에서 일을 하고 있습니다. 저는 삼성, 하이닉스, 그리고 내셔널 나노팹, 디스트, 카이스트과 같은 한국에 있는 메이저 업체뿐만 아니라 한국에서 필요로 하는 반도체 인재를 양성하는 그런 곳에서 필요로 하는 클린룸이랑 이런 것들 진행했던 경험을 갖고 있습니다. 오늘 이 자리에 같이 참석하게 돼서 반갑고요. 저희가 알고 있는 모든 지식들을 알려드리도록 하겠습니다. 감사합니다.
Hello, this is the Jae Kwon from Aron Korea, and it's glad to meet you everyone. And Aron Korea has been working in the Korean semiconductor industry for 24 years, building the infrastructure of the clean room and utilities in Korea, not only the big companies such as Samsung and SK Hynix. We also provide the attendee system for the local education labs such as the university lab for semiconductor or also the R&D center for the equipment company as well. And we would like to share our experience to build up factory and also the utilities and clean room. Thank you.
Thank you everyone for the introduction. So I'll start the discussion with Satish. Since you have spent all your life in semiconductor fab, so if you can please highlight what are the challenges of building an operational semiconductor facilities, and what are the key things which government and the other stakeholders can do to expedite the development of the facilities in India.
Thanks, Mark. Let me begin by saying that the semiconductor chip manufacturing process is a very complex process. It's a high precision process. So the equipment that is used in this process are quite complex, quite sensitive, and quite very high precision equipment in terms that geometries of 28 nanometers, and we're talking about in nanometers. So all the process is required to be carried out in stringent environment, clean rooms with controls on all the environmental parameters. Multiple utilities are needed for the process, and very importantly, the safety involved, because lots of high purity grade chemicals and gases are used, and most of these gases are hazardous in nature. Now, coming to the so all these complex processes, and the support system entails, very critical design and intricate design of the facilities, and the construction aspects also are equally challenging, but nonetheless not insurmountable. So let me talk about a few critical systems that go into the semiconductor facility, operational facility. The first and foremost are the clean rooms. The clean rooms are the heart of this facility where the chip manufacturing takes place. So we are talking about even a speck of dust can affect the performance, the reliability of the chip significantly. The yields will be very low. So we have to control on the particulates, not only on the particulates, but equally importantly the temperature, the humidity, the static dissipation, the pressurization. All these parameters are to be maintained in a very stringent manner, very controlled manner, so that the right environment is available for the chip manufacturing. So the design of these clean rooms involves a proper airflow management, proper selection of the materials that are involved, like the floors, the wall panel, the ceilings. So all these materials have to be non-shedding, they have to be static dissipative, non-corrosive, so that they don't contaminate the environment, the clean rooms. So it is very important that the design is done in a manner that all these parameters are strictly maintained, because any excursions will directly affect the chip manufacturing, the quality of the chip. The second important aspect is in the building itself, the design of the building itself, the structure, because these equipment are quite vibration sensitive. So there are vibration criteria that are defined for this, particularly the lithography equipment, as Mr. Sagar mentioned about the EUV tool. So those are the tools which create the geometries on the wafer. So any effect of micro vibration, we're not talking about the large amplitude, we're talking about very small micro vibrations. So particularly these vibrations are defined by the equipment manufacturers. So right at the beginning itself, the vibrations are measured on the ground. What are the vibrations coming from the surroundings? So it's very important that the fab is located at a plot where there are no vibration inducing surroundings, like the railway tracks or high speed traffic. So that the vibrations are mitigated. In the design itself, in the structural design itself, the vibration criteria are introduced, and apart from seismic and other considered, that's okay. But the vibration is one important aspect in the design of these buildings. The third important aspect is the gases and chemicals. So there are high purity gases and chemicals which are needed for this thing. And as I mentioned, there are about 45 to 50 gases that are going into the process of the chip manufacturing, and another 50 to 60 high purity grade chemicals. And most of the chemicals are acids or the slurries and the photoresists. So these are high purity grade, gases are high purity grade, but importantly, those are also very hazardous in nature. So the transportation of those gases, when I mean transportation, it means within the facility from the source to the tool where they are used in the process, has to be done in a piping network, the integrity of which has to be maintained to the utmost, because any leakages or gas leakages in PPV levels or PPT levels, that is very hazardous for the human beings. So the safety systems are to be put in place. The piping network for these gases and chemicals is a specialized work, not only in design but in execution also. Because so in India, earlier we did not have the specialized workforce, but after having set up the facilities in SCL, we could develop some manpower here in India. So now it's only the scale and the speed with which they have to come to cater to the emerging semiconductor fabs in India. And lastly, the important aspect that I would like to mention is that the whole construction, because it's a 4-story building, the fab is a 4-story building, so we have to expedite the construction in a way that it is done in as early as possible, So innovative ways of construction are to be introduced, like the prefab construction, the modular construction. We have to segment the fabs in parts, so that at least one part gets started and the equipment and the process gets started. So these are some of the challenges, but I think in India we have the right resources. The clean rooms are being built in India, but for semiconductors, the clean rooms are a bit more stringent. So there is a differential know-how that is to be acquired by the Indian design companies. Likewise for the process, tubing and for the chemical distribution, gas distribution network. There is a need. There are experts, but some more capacity building and some more expertise needs to be introduced in the country. So these are some aspects I wanted to share.
Thanks, Satish, for giving this entire perspective of the semiconductor fab. Now from fab, we'll go to the back end. So we have Varun, they are running and packaging the chips already. So Varun, if you can also highlight the operational challenges and what kind of efforts which can be done from different stakeholders to expedite the development of the ecosystem in the country.
Sure, thank you so much, Sagar. I'll go back to 2020, which is when we decided to start this project, and much before ISM was born, and much before a lot of talk around semiconductors was happening. So it was an extremely difficult task for us to find any vendor, right? When we started to talk to clean room companies, the closest that people could come to was in the pharma space. So that's obviously an area where clean rooms are available, but still the difference is quite large when you talk on the nitty-gritties. But yes, finding partners for construction, the clean rooms, even the gases, etc. So nobody had really done the purity level that is being spoken about. But yes, once we decided. So we had to use and obviously during the 2021 period. Travel to all the countries which are masters in this space, whether it's Japan, Taiwan, Korea. It was very difficult to travel there, get knowledge, etc. But I would say we had good partners and friends in the industry who guided us to move in the right fashion. So one experience which I can share is that once you build a clean room in this space, you realize that the clean room is the cost of the civil construction. So it's a heavy investment in the clean room. So we have a 4,500 square meter clean room divided into two parts of class 10,000 and class 100,000. And maintenance of this clean room, as my colleague also spoke about, a fab is obviously a lot more advanced, but even at the OSAT, maintaining the clean room is very, very critical and very important. So that's one thing I want to speak about. The second is when you're building an OSAT or definitely a fab, movement of material and transporting your material is very, very critical on how you handle it, because the wafers at the front end right up to the packages at the back end, they're all very sensitive devices, especially wafers. When they come in, they are 750 micron, you back grind them, they come down to as low as 150 micron. So handling these wafers is very, very critical, and therefore choice of the equipment that is needed to handle them, whether you do it at the ground level or you do it at the overhead level, one has to plan for all that in the beginning rather than doing it subsequently. Additionally, when an OSAT is switched on, it cannot be switched off easily. This is not a 9 to 5 thing that you just switch off the lights and you go home. So once you power it up, it becomes basically a fully functioning facility at all times. Now, when we are in the startup phase, that's the challenge, that how do you manage this? Because building this entire 4,500 square meter clean room, obviously at the startup phase, we're not occupying all of it from day one. So we worked with the teams from the vendor sites and from the project planners. And we divided our entire facility into phases, whereby we've built up everything from obviously ground up, and everything is fully ready. But we managed to switch it on in parts, so that whenever we get in, more equipment and more lines, we can just bring the equipment in and start. So the facility is built as a plug-and-play facility. However, only a certain portion was occupied, so that as and when we grow, we scale up, we can bring in other equipment. So these are some of my inputs from an OSAT standpoint. Thank you.
Thanks, Varun, for the perspective. Now we'll move to display. So display is also, the key component in the ecosystem, and Government of India has incentive and schemes for the display manufacturing as well. So while you have seen display fab across the world, and you build display labs, in different part of the world. So would love to know from you about your perspective about how we can have a very robust display manufacturing ecosystem in India, and what are the different steps which different stakeholders, including the government, can do to further facilitate. Over to you.
So in 2015, I recruit and build a team around 200 technicians from Taiwan, and we built the first fab Gen 8.6 in China. So at that moment, we didn't have any technical partner. We built the fab on the green field by our own team. And in the coming 6 years to 2021, our team built 4 fab. All the 4 fab is a Gen 8.6, and the total capacity is 660K. That's almost 10 times than our project in India. Yeah, we submit our application with a 60K Gen 8.6 fab in India. So I just want to show that we got a lot of our team got a lot of experience about this kind of things, and I think this kind of a capital-intensive industry, like a display fab and a semiconductor fab. So at the beginning, the static friction is very huge. So need a government to put eliminate this kind of a static friction to make the fab move. So subsidies from government is very important to minimize the risk. And I think maybe government can provide a single window, like a green channel, to simplify the kind of application, not only for subsidies, because foreigner visa, tax, kind of law or regulation for a fab construction is also very important. And I think that to develop the supply chain or ecosystem, it's just like a black hole in the universe. If there is a black hole in the universe, the time and the space will be disturbed. So if we can put a fab in India, then the ecosystem will be disturbed. That means will be attractive to India. I think that's the most important thing in my mind. Yeah.
Thanks, Vijay. Appreciate that perspective. Now, sorry, thanks, Vijay. So I think the other, I'll directly go to the aspect of the supply chain. So semiconductor supply chain, is very complex. A typical chip crosses international borders 70 times before it's getting to the final product. And if you see today, there's a lot of concentration of the semiconductor supply chain. For instance, 92% of the most advanced chips are getting produced only in small geography. So we are at a very precarious position that way. So when Government of India thinks about these policies, etc., so we are very mindful that how we can be be a participant in making the supply chain more resilient and diversified. In that context, Mr. Kuan, if you can share your perspective that how we can further build on whatever efforts we are doing, and in order to especially with respect to raw materials in the equipment supply chain, to make a very robust ecosystem and a very robust supply chain for the raw materials and the equipment.
일단 지금 저희 반도체 관련돼서 이제 인도는 파마시 쪽에는 인도가 강점이 있다고는 하지만 아직 반도체 쪽은 이제 처음이고 거기에 대한 준비들이 굉장히 많이 필요할 거라 생각을 하고 있고요. 한국 같은 경우에도 지금 하이닉스나 삼성들이 워낙 반도체 쪽을 많이 하다 보니 반도체 강국으로 알려져 있지만 처음에는 한국도 지금 인도처럼 똑같은 문제점들을 안고 시작을 했었습니다.
So first of all, India has a strength in different industries such as pharmacy area. However, semicon is the beginning step in India currently. And in Korea case, as we know, Samsung and SK Hynix are big and we are well-developed country as a semicon suppliers. However, there was a beginning stage in the Korea as well, which has struggled to build up the ecosystem.
한국도 초창기에는 어려운 겪어서 했겠지만 지금 저희 한국이 반도체 강국으로 커질 수 있었던 것들은 주위의 인프라들이랑 기반 시설들이 굉장히 잘 갖춰져 있기 때문인 거고요. 그런 원자재랑 이런 필요한 소스들을 저희가 외국에서 수입할 것이 아니라 한국 자체적으로 그것들을 해결하기 위해서 굉장히 많은 노력을 했었습니다. 하지만 지금 저희가 인도에서, 저도 오래되진 않았지만 인도에서 1년에서 2년 정도 경험을 가졌을 때 아직 반도체를 시작하기까지는 아직 그런 기반 시설들이 준비가 덜 됐다고 생각을 하고 있습니다.
So when you build the fab in Korea, there was a lot of different companies following up to build an ecosystem to supply the raw material and also the HR, the manpower, and etc. And this is the fundamental to build the ecosystem of the semicon area. We have experience in India for solar system currently, and for building a semiconductor is not only just build an infrastructure fab for just manufacturing the semicon fabs. It needs to be supportive for the ecosystem building. It should be followed, and India should be ready to build the raw material to the manpower to run the fab.
지금 반도체 쪽을 하기 위해서는 수많은 가스들이 필요할 거고 물론 반도체 시설을 구축하기 위해서도 더 많은 자재들, 원로 머테리얼 이런 것들이 필요할 거지만 이런 부분들을 직접 해결할 수 있게끔 정부에서도 인도 정부에서도 많은 외국인 기업들을 유치할 수 있도록 도움을 주셔야 될 것 같고요. 그리고 저희가 실질적으로 일을 하는 데 있어서 가장 문제점은 저희가 직원들이 와서 한국 직원이든 저희 해외 직원들이 왔을 때 일을 하면서 항상 비자 관련된 문제들이 굉장히 많은 이슈들이 좀 있었기 때문에 외국 사람들이 얼마든지 여기서 일을 할 수 있게끔 그런 프로세스 같은 것들을 조금 단순화시켜서 저희를 좀 지원해 주시는 그런 부분들이 좀 필요할 것 같습니다.
When the beginning of the building the ecosystem, there will be a lot of support from different countries who already gone through those stages. And for that, it should be simplified the process for foreign companies to enter to India to support the semicon industry. So there were some difficulties to get the visa, as others mentioned, and also for localizing the materials. It's not only about the gas, like 40-50 different specialty gas and chemicals need to be supplied inside India, and not only about the raw material, but also there are some consumption parts which necessary to consume every single part if there is no ecosystem building internally in India, at the end there will be no competition on the market as well. So there is a lot of support for foreign country companies to collaborate in India in the beginning stage.
감사합니다.
Thank you so much.
Thank you for the perspective, and I think we are committed to support, and please feel free to reach out to us for any support regarding the challenges which you are facing. So now coming to, you guys have now understood the complexities and the challenges associated. Now we'll come to the construction part. The fab construction is not just about civil engineering, but a lot of complexities involved. So we have Arun with us, and we'd like to understand from you about different challenges, and also at the same time, what kind of partnerships and arrangements that can be put in place to further strengthen the fab construction and related ecosystem.
So large semiconductor fabs, these are fast-track projects, and it involves a very close relationship between engineering, procurement, and construction. And not only within engineering itself, it's a lot of these projects that get done globally, they use as benchmarks for design and construction and planning projects that have gone before that. So usually they are smart copying something that that particular company has already done, and this something for us is a bit of a change, which so not only just a smart copy, but if you do that, as a fast track, you need to be able to do procurement and construction while engineering is still going on. So that means you actually need to do engineering also in several stages. While you're doing the concept, you want to fast track your piling and foundation. So you need to already be doing detailed designing and then procurement. So there is a lot of parallel activities going on, not just in the various facets of engineering procurement, but within them as well. You are relying on a fairly close participation of the various players, that are stakeholders that are involved. And for us specifically, when we are going to be working with companies which are overseas, and they may be also be language barriers, and as we start with this benchmarking and smart copying, we need to also bring all of that to India, and then so convert that to something that we can design and construct in India, and at the same time, we are dealing with trying to do the procurement specifically of a supply chain which is extremely weak in India. So a lot of the fast track projects that are executed depend on this close relationships within the various aspects of the design, the relationship of the execution company, the contractor, with the procurement, the vendors of that. So they are already contributing ahead to what the design is going to be. So a lot of the scoping of these packages, which are these performance packages which support the process, ultra-pure water, wastewater treatment, gases, chemicals, process exhaust. A lot of these are vendor-driven. Some of these are actually even bespoke to the particular problem of that fab. For instance, what is the process, what is the mix, what is the demands of that particular process, and therefore the solution then gets worked out. And this is often happening in parallel to the actual designing that is going on, and then you're already mobilizing at the site and you're doing construction. And for all of this to happen in a fast-track manner, with stakeholders and partners who are used to working with each other, in itself is a challenge. To try and do this where such relationships are not in place already, where you need to then additionally bridge that gap, not just of location, but of culture, and the missing supply chain gets harder. And so there are all those issues, and then construction itself. So what you do with the constraints in capacity of, let's say, the Indian steel fabrication, or almost missing precast capability for this particular industry. It doesn't exist. So I think there are several challenges to be addressed, and then there is even more case for a risk-driven project management, in which several of these concerns need to be addressed in parallel, and solutions need to be worked out. It really asks for an extremely cooperative group of close coordination between the stakeholders, which I think will need to transcend the traditional barriers or contractual relationships which exist between, let's say, the owner, the engineering company, the procurement, and the contractor. Yeah. So I think these various stakeholders need to come together for a bigger commitment, realizing that what we face here is a challenge which is even a step more complex than what a similar project would be overseas. And I think it's only with a mindset like this that we can, start to address these issues in a proactive way, to start to put these solutions, identify the problems, put the solutions in place, and then work together to make actually this happen. It is a tall order, and it will take a concerted will to succeed.
Yeah, thanks. I think working together is the way forward. So now, Vishy, Micron is building advanced fabs globally, and also doing advanced back-end processes. So though, as Secretary Krishnan highlighted during the inaugural session, that for us, for now, 28 nanometer is the sweet spot, and we are working on the technologies like flip chip and wire bonding. But we do have aspiration to go to HPM, or we do have aspiration to go to FinFET and then gate-all-around, etc. What is your perspective? How, like, as a government, our research institutions, our academia, our industry, how do we think to sort of trace that part and go towards the advanced semiconductor manufacturing?
Thanks, Sagar. I think just to tap what Arun mentioned in the closing, I think it first starts with the mindset. It's really about committing to excellence. So when we talk about things like clean room, I think the critical part in the clean room is the design and contamination, right? So if we take a laxative, just a lighthearted approach to design, meeting the spec, but not paying too much attention to, the particle content, the temperature, the humidity, that can be disastrous, even for, just an entry-level semiconductor manufacturing. So we have to learn to crawl before we walk, walk before we run. And we need to be committed to the process of excellence, committed from an infrastructure point of view. I think it was mentioned earlier in the conversations, we do not ideally want to see from a quality of power is a very, very high priority, especially in a semi space where semi 47 standards are very, very critical, very, very hard to meet. Even a power dip can be very, very expensive depending on the scale of operation. So it's critical to, as we enable, N or N+1 or N+2 power supply sources, it's critical to ensure that the quality of power is is par excellence, is 100%, is available 100% of the time. That's a given. That's what we see in other geographies across the world, and that's what we should strive to push forward if we want to be a big player in the semiconductor manufacturing space. The other aspect of, we talked about vibrations, we talked about things that we see around us in the environment. What we also see is we pay a lot of attention to some of the basic infrastructure, but some of the important infrastructure, like things like the roadways that are adjoining to a semiconductor manufacturing should not have a lot of heavy traffic movement, because that's going to create vibration. That's going to create dust. That's going to create a lot of the things that are not favorable from a semiconductor manufacturing perspective. Last but not least is the drainage systems, right? I think we really need to take that very, very seriously. It's important to ensure that drainage systems around all of these industrial parks are devoid of foreign particles, foreign elements. I think the government has done a lot of things from a effluent perspective, treatment perspective, but some of these things is very important to ensure from an infrastructure perspective. And last but not least, I think we have an opportunity here. Sustainability, a lot of companies are talking about sustainability. How does the Indian ecosystem has a lot of investment in renewable energy. How does that come back and work with some of the promises or commitments that semiconductor companies are making in terms of being carbon neutral in the future? So that's another opportunity that we have ahead of us. So I think if we do a lot of these things together, as we scale, as we advance from one product generation to another, those products that you mentioned earlier are not beyond us. I mean, we need to do some of these things first, though.
Thanks, Vishy, for the perspective. And on the sustainability bit, I'll put some data there. So currently, our installed capacity is 425 gigawatts. And we are today exporting electricity to our neighbors. And out of that 425 gigawatts, 183 gigawatts is from non-fossil fuel sources. That's our commitment to the climate change and the kind of efforts which we are doing under the leadership of Honorable Prime Minister. So I do have some more questions, but because of the paucity of time, I'll just request from the audience if there are some quick questions, we can take those before we conclude the session. So can you please hand the mic over?
Hi, my name is Kunal. I come from a company called Molson. We work on battery materials. The question is very inward focused. Indian chemical industry, especially the medium and small scale, has been backbone of all the industries that we've seen grow, especially connected with chemicals. My question is to the panel here, what directions can you give for Indian chemical companies, especially like ours, which is in medium and small scale, trying to aspire to be a part of this supply chain, whether from trade or whether from producing something for the industry? What is the directions that you recommend for us to look into so that a year or two down the line, we can be an integral part of somewhere in the value chain, if not exactly selling to you, but identifying the pockets of research and development that we can undertake at this point in time? And if I can add one more, how critical is power backup in your entire construction? And what is the options that we're looking at power backup, what capacities we are looking? You can skip this question if the answer is not ready right now. Sir.
So Varun and Satish. Okay, Varun, you can start, and probably Satish also can add.
Yeah, as regards the power, you see these tools, as was mentioned, are very power sensitive. Okay, so even if a dip of half a cycle is there, this will trip. Okay, and tripping means you have to requalify the tool, restart the tool. It's a hard shutdown. And then in the process, we lose lots of parts because they're all moving parts, robotics are there. So we cannot afford any power dip. So backup has to be there for the at least the equipment, 100%. Okay, so this is without any compromise. That's why it was mentioned that we need to have a very stable supply and a very dual circuit supply with 100% backup for at least the critical tools and the utilities. That is the importance of this facility.
So I think Varun also has a point there.
Yeah, to answer your question on the chemicals, so I think first of all, identify what is getting used in the industry, both by fabs and OSATs. Understand what are the materials getting used, the types of chemistries, and also which chemistry you're targeting. I don't think you can target everything in one shot. So what are you targeting? And try and see that if you can collaborate with some of the international chemical suppliers who are already supplying chemicals of that purity, whether it is tin, it is, whatever the kind of chemistry is required. There are several companies in Singapore, Malaysia, Korea, Taiwan, who, because the chemicals industry is, it's not easy to just do a direct export. It's hazardous chemicals, and there are several shipping restrictions, etc. But they would be looking to find partners here, I would say. So if we can look at collaborations with people like these, I mean, one of our suppliers has done something similar, and we helped them tie up a company in Ahmedabad to the supplier in Singapore. So you start with, even helping them in trade of the chemicals here, and then work out the deal at your end if you can, work on some formulations here or, whatever needs to be done. But identifying the chemistries that you need to target is probably the first step to go ahead.
I'll just add to it. I think based on my experience also of talking to the global chemical and raw materials manufacturers, they follow exactly the same model with the local supply chain vendors that, and they also want that the localized supply chain. So identifying and then working with them, it takes, like, from a normal chemical to the semiconductor grade chemical, it takes some time. But they are willing to put that kind of efforts and partnerships. They're looking forward. So you can reach out to India Semiconductor Mission for any support in that regard, and we'll be very happy to support you in that endeavor. We can take one more question probably. Yes.
Hello. Yeah. Thank you, Sagar, and thank you, panelists, for the wonderful moderation and discussion. I am Gawak Joshi. I am from Namtech. And my question is to Mr. Vishy and Mr. Satish. You talked about the importance of creating skilled manpower. So what strategies you can think we can implement to create this kind of manpower, like from entry-level graduates to the skill-ready workforce?
Yeah, thanks. I think we've spent some time talking to Namtech about some of the aspirations that Micron has. Our aspiration actually is that every new employee is ready from the get-go, ready from day one, right? Now, that's a challenge, but I think we have opportunity here because we have other people coming into Gujarat having the similar aspiration. So there is an opportunity for a consortium of sorts in terms of skilling, where companies come together and say, this is our end goal in mind, that we would like to see people coming in who are industry ready as they join. And just to give an example, we had some interns in their final year who interned with us, right? Coming into our internship program, they did not know much about semiconductor manufacturing. They had very strong engineering background from universities in the Ahmedabad area, but they did not have direct experience in semiconductor manufacturing. With 3 months of experience, hands-on experience, they were able to make an impact internally within Micron, where some of the ideation that they came up with was, implemented to impact the bottom line. So I think it's definitely doable as long as you have the hunger and aspiration to learn. The capability is always there at all levels, be it an operator, technician, or an engineer, a fresh graduate. I think it's again goes back to the hunger to learn, and the opportunity for us is also how can we kind of create the COE, a center of excellence, where training is provided, or is some level of practical training is provided prior to their entry into the industry, and that's what Micron is also aspiring to do as we work with some of the local universities.
So you have rightly mentioned. So my suggestion is also that we must introduce courses at the undergraduate level, okay, like device physics and the semiconductor technology, so that the graduates coming out of the college, they become industry ready to some extent. Of course, they would need hands-on training on the tools, but at least they will have that background of the technology and the process. So that is one recommendation that I would like to give.
Maybe I add a little bit. I believe IIT Gandhinagar is planning a special organization under them, which is going to take this up on an active basis. And we also had a discussion with them, not just on the manufacturing side, but also on the skilling for on the construction side, for the trades, for the clean trades. And these are skills otherwise which we would need to import from overseas, and that's an expensive proposition.
So thanks, panelists, for giving this perspective. And I think as all of you now realize that semiconductors, it's not easy, and that's why it is a lot of fun and challenge and and scope to sort of enable this ecosystem in the country and to be a trusted partner in the global semiconductor supply chain. So I request each one of you to work together with all of us to bring this industry to India, to contribute a lot of value to our economy and the prosperity of our nation, and also on our fundamentals, Vasudhaiva Kutumbakam. We understand the semiconductor supply chain is so important. We sort of, I think, we interact with semiconductors so many times during the day, and they are an integral part of human civilization now. It's like steel for the modern civilization. You cannot have a robust digital infrastructure without semiconductors. So I think on that note, we can conclude this session. Thank you so much to the audience, and thank you so much to the panel.
Thank you so much, Mr. Sagar, and thank you, the insightful panel discussion. A big thank you to our panelists for sharing their expertise and to our audience for their active participation. We'll request Mr. Sanjay Garden to kindly felicitate all the panelists and the moderator. Ladies and gentlemen, that concludes our session on high-precision fab construction, clean rooms, and semiconductor equipment localization. We hope you found the information valuable and the discussions thought-provoking. Please stay tuned for our next session, which is on supply chain management for chemicals and gases in the semiconductor industry. We take a real short break of 10 minutes only, and then we assemble over here for the next session too, which I repeat is on supply chain management for chemicals and gases in the semiconductor industry. And all the panelists and moderator, we request you to kindly step forward for a group photograph. Gentlemen, we request you to step forward for the group photograph. Thank you, and can we extend a round of applause for all the panelists and the moderator? Thank you, ladies and gentlemen.